So for this example, we are going to look at a more dense user interaction with more, more of a series of user transactions, um, and show what we can do in the way of good user design. So this example number two, is going to be user information entry. What we're going to do is essentially collect a mailing address. If you think about that, the usual data that the user has to enter is fairly self-explanatory, right? We're going to have the name, the address, and the phone number type data. Is that an exclusive list of everything we need? Probably not, but it's a good starting off point. There are some other things to consider though. When you're going into addressing the needs of these problems with the solution, don't just sit down and start banging out a solution. You really do need to go through and address some of the additional concerns that your user is going to inject into your process. So, what are some of those concerns and how will the user look to enter data? Firstly, what are they going to do? Are they, are they going to use their keyboard? Are they going to use a touch screen, so like an iPad or something? That may have some impact on how it is you want to design your solution at the end of the day. Um, Look at any place it is. This is the second from the last bullet point. Look at any place it is where something can go wrong. What we want to do as program and process engineers is to reduce any possibility of error. And that is especially true when we are working with data. The problem with data operations is if you get garbage data in, now you're going to put garbage data out, and that's something that you don't want to do. So here, for example, with a mailing address, uh, we want to reduce the probability that a user even has the opportunity to have the mail sent to the wrong place. So we'll look at that a little bit more in depth as we get there. And finally, what can we do to help eliminate inconsistencies in our data? Do we want to provide data for the user? Do we want to go back and double check that they have everything in there? Um, it's your job, frankly, as a programmer, a process engineer. It's your job to ensure that when everything is said and done, when the program has run its course, that the data it is we walk away with is actionable, it's usable, it's good, it's complete. Um, so it's best to start thinking your way through that now so that we can be reasonably assured that it's good on the other side. So let's take a look at what the problem definition is and how it is that we're going to go about and solve it. So here we are with the problem definition. So this will be a very narrow problem definition, but we can fill in the blanks kind of as we go along. So the problem is to create a program where a user enters data for a mailing list. When the user is done entering their data, the next best thing to do from a design perspective is to have the user confirm that the data is correct. So if you think about any interaction you have had, filling out an Amazon order, filling out an online order of any sort, if you're going to get something delivered to you via, Grubhub or whatever, you are going to go through and actually confirm your order. There's two reasons for this. Number one is it's actually for data correctness. That is helping, to maximize the probability that what the user entered was correct. So if you think about removing small inconsistencies like the transposition of numbers, if I mean 3301 North Mulford and I accidentally type in 3103 North Mulford, asking the user to go back and confirm helps to reduce those inconsistencies. The next kind of user-facing design consideration that helps address is that the user is looking for some sort of confirmation, right? They want to know that the data that they've been entering has, number one, been heard, that the system is going to do something with it, and that number two, that there, those actions have a consequence. So if that's, getting Chinese food delivered, or if that's getting an enrollment packet or whatever it is that we are looking for here with the mailing list, getting that sent out to you. So they're looking for a consequence to their action, and creating some sort of dialogue, a display that says, here we have, number one, received your data, and that number two, that there is a consequence to that. Consequence can be a positive thing, right? So something will be mailed, you will no longer be hungry, whatever the case may be. So what we are doing is we are going to create a program where a user enters data, and that the user will confirm that their data is correct. Now, just to go back and forth between the two, the problem definition and our actual solution algorithm, here in white, I have for you the problem definition, and here in black, I have for you the algorithm solution. So this again is Sublime Text. Again, the only real benefit here is to have line numbers. Certainly this is something that were you to follow along, you could do in Word or Notepad or text editor, what have you, or go ahead and grab a copy of Sublime Text and follow along with us. So first and foremost, as per usual, we do need to have a module name. So module user data entry, to also let the next developer in the chain know that there's a beginning and an end to our solution algorithm. When we start a module here on line number 2, we should also end the module here on line number 5, and that is going to be, the termination of our solution algorithm. I am just going to add a little bit more white space in here, empty lines. I'm going to remove these later on, but certainly while I'm talking to you guys about it, a little bit of additional white space makes my life all the easier. So first and foremost, what we are going to do is let the user know what it is that our purpose is. We want to let them know why it is that they are entering data. Now, we're going to do that with a display. What we want to do is let the user know what's going on, and we want to use our prompting to let the user know how to actually engage in a successful transaction with us. So here on lines 4 and 5, that's what we're doing with these displays. We are displaying welcome to the, I can't spell correctly, welcome to the Rock Valley College new student forum. Please enter your mailing information and we'll get an enrollment packet to you ASAP. So we are letting the user know that there is a consequence to their action, that once they enter this data in, they are going to receive an enrollment packet on the other side. So we have to start this interaction someplace. So what we are going to do is start it by asking for their name, right? So display, please enter your name. And we are going to get that name. So that means that we are going to receive from the user whatever data it is that they are putting in there. The problem with just doing get your name is as follows. And I know we've mentioned this before, but it bears mentioning again. There's different ways for you to put your name in here. There's first name and there's last name, right? So if we have people who are coming from military or prison or European backgrounds, they're going to put their last name first and their first name last. That's not necessarily going to jive with us for how it is that we're expecting our data to come into the system. So if I simply ask them to enter their names, what I am going to essentially do is I am going to produce a little bit of uncertainty into our system. I am giving them the opportunity to be wrong, essentially. So better than that would be to request their first name, their last name, and potentially their middle initial. This way, I'm helping the user manage our system. I'm helping the user adhere to our data protocols in very, very short order. Now, everybody has their, we've heard customer service stories where everybody's kind of an idiot, and that's not necessarily the case. I'll tell you, it is much easier to develop programs and processes where you do not assume that every one of the people who is going to be involved in your process is somehow brain damaged. It's funny when you talk about it with your peers, but it's not necessarily funny when you do that from a development perspective. So make your needs known and expect for the most part that your user is going to adhere to those needs. So here we are requesting, it's line number 8, first name. We are requesting and getting on line number 10 and 11. Last name, and here on lines 14 and 15, we are requesting and getting their middle initial. You'll also notice here still with the variable names, we are using camel case or mixed case. The first word is all lowercase, and the first letter of any subsequent word is uppercase. So now we have a better solution for getting their first name and their last name. So if we need, and their middle initial. So if we need to keep this going, we are going to need to get their address. So the problem with making the request, like we see here on lines 18 and 19, is getting the address has so many different implementations that, again, we're leaving a lot of chance to how it is that the user is going to enter that data. So here is on lines 21 through 26, different possible ways for people to enter data in. 3301 North being all the way spelled out, Mulford Road, Rockford, Illinois, 61114. 3301 North, just a capital N, Mulford Road, Rockford, Illinois, 61114. You'll notice we have on line 21 a comma. You'll notice we have on line 22 no comma. Here, line 23, technically speaking, this is a correct data entry, is 3301 North Mulford is the address. It's leaving out the full address, so we do not have city, state, and zip data there. But technically speaking, the user is at 3301 North Mulford. The user is entering in data the way that we have requested it. We have Rockford, Illinois, incomplete. We have Rockford, ILL, incomplete and wrong, right? We have Rockford, which is way off the beaten path. And frankly, what's to stop us if we just have a user having an entry point? What's to stop a user from saying, I live at Blueberries, figure it out? Nothing, right? That's a terrible answer, but we're not correcting for it, right? So here, potentially, when we're asking a user for their address, they can say Blueberries, prove me I'm wrong. We really don't want that. We want to lead the user through this interaction in a way that is the most precise, because the more precise we can be with them, the most reduced the chances are that they're going to enter incorrect data. So here we're going to display requests for house number, street name, city, state, and zip code. In so doing, hopefully we are leading the user to a more complete interaction with our program. So after this, we will notice that the program has two pieces here. We are going to get the user to enter data for a mailing list, and we are going to confirm with the user that the data that they have entered is correct. So the next piece here, what we need to do is to actually take the data that the user has entered and display it back for them. So this next piece here, lines number 32 through 35, display. Now let's see if this is correct. We're going to display first name, middle initial, the period, and the last name. This is on line number 33. On the next line, we're going to display house number and street name. And on the next line, we're going to display city, state, and zip. If you'll notice, these three lines, number 35, 34, and 33, going backwards, are the way that you would see the data in a mailing address. What we are doing here is we are meeting the expectations of our user by formatting the data in a way that they are used to. If the user is going to look at something that's going to look like a mailing address, show them that data in a format that is going to look like a mailing address. The more you can mimic the expectations of your user, the better the user is going to be at actually being able to interact with your solution. The very last thing that is required of us is we are going to confirm with the user that the information is correct. So here on lines 37 and 38, display is this correct? Let's be a little bit more complete here, yes or no, or something to that fashion so that we can limit the kinds of inputs that the user is going to make. By doing this, suggesting a capital Y or a capital N, we are reducing the amount of work that we have to do programmatically to sort that out. What happens if the user enters in "you betcha"? Right, we've got the same jackwagon user who said, I live at Blueberries, and is Blueberries correct? You betcha. So they're being a total jackwagon here. Well, we're giving them the opportunity to do that. So by suggesting that the only two correct responses are capital Y or capital N, we are giving to the user a very, very small sample set of correct responses. And hopefully what we're doing is we are reducing the potential for error that they're doing there. So this is it from lines 2 through 40, and bear in mind we have numerous lines of white space, essentially just empty spaces, so that the user or the next developer in the chain rather can see that these are discrete portions of a program that go together. In less than 40 lines, we have a full and complete set of instructions that is going to let the next developer in the chain know exactly, number one, it's going to let them know exactly the kinds of data that we are looking for. So first name, last name, middle initial, so on and so forth. It's also going to let the next developer in the chain know exactly how it is that we want the displays to go. We are letting the next developer in the chain know, look, this is the interaction I want the user to have. These are the pieces of data we believe the user is going to need in order to correctly enter the data that we're looking for. So all of this, these 40-ish lines, convey that. These are the messages we are hoping to convey to the next developer in the chain. These are the messages we need to convey to any and all of our end users, and this is exactly how to do it. If we can produce this for pseudocode, we can be confident that when we hand this off to the next developer in the chain to go into a compile and run environment where this is going to be actually developed and distributed, we can be very, very certain, or as certain as possible, that the solution we had in mind is going to be implemented. And that's the exact reason that we have pseudocode in the first place.